Hey.
What are you doing?
I'm just trying to get fit, girl.
Well, how many laps have you run?
This is my first one.
That's it?
Yeah. I'm just kidding. This is 27. So this is my 27th lap.
Well, how many miles is that?
Not quite sure.
Well, can we figure it out?
Yes, we could. I'm a math teacher. All we need is a tape measure and 2 measurements from the field, and we could get a good approximation of how far I just ran. So, give me a minute. I'm gonna go get my tape measure. I'll be right back. Got it. Okay, so what I'm gonna do is get 2 measurements from the field. I'm gonna get 1 measurement down here at the end of the field, and I'm gonna get another measure along the side of the field. And from those 2 measurements, we will be able to figure out the distance around the track, and then we'll also be able to figure out how many miles I ran from that. And one other thing we'll be able to determine is the amount of area that this field encompasses. So how much area is this entire field out here between the track? So those are the 2 things that we're gonna try to find. Let's go.
To help us calculate the distance around the track, we are going to need a formula for the circumference of a circle, which is pi times diameter. This is an overhead view of the track. As you can see, I have split it up into 3 different sections, a rectangle in the center, and 2 semicircles on the end. I recorded my measurements on this diagram. I measured 330 feet down the length of the field and 210 feet across. From the 210-foot measurement, I was able to determine that the circles are going to have a radius of 105. Now we are ready to calculate. Now that I have 330 on one side, I can multiply it by 2 and get 660 feet. So I know there's 660 feet on both sides of the field. Next, I need to determine the distance around the outside of each semicircle. To find the distance around a full circle, we use the formula pi times diameter. In this case, we have 2 half circles. If we put them together, that's the same as having 1 full circle. So, what I will do is I will multiply 3.14 times the diameter, 210. This will give me the circumference of both semicircles put together. If we take the 659.4 divided by 2, we now know that there's 329.7 feet around the ends of the field of the semicircle. This would be our final measurements for the distance or perimeter around the inner part of the track. Determine that it's 660 feet just for the perimeter of the rectangle portion. We then determine that it's 659.4 feet for the 2 semicircles put together. This results in a total perimeter or distance around the track of 1,319.4 feet. So we know that there are 1,319.4 feet around the perimeter of the track. There are 5,280 feet in 1 mile. So I take the number of feet around the track, divide it by the number of feet in 1 mile. So I rounded this to about 0.25 miles, which would be 1/4 of a mile. I did not run 1/4 of a mile because I ran more than 1 lap. So in order to determine how many miles I ran, I would multiply 0.25 times 27. This would give me 6.75 miles, or 6 3/4 miles. To help us calculate the area of the field, which is the grassy part, we will need to use 2 formulas. That would be length times width for the rectangle, and pi times radius squared for the circle. This shows that we multiply the length and the width of the rectangular part of the field to get an area of 69,300. Plug in your values for the variables and simplify the expression. This shows that we're using the radius of 105 feet, which is half the diameter across the field. Plug in the values for your variables and simplify the expression. Be sure to use 3.14 for pi. The total area of the field is the sum of the rectangle and semicircle regions of the field. The total area of this field is 103,918.5 square feet.
What did the runner say to the track? I like the way this field's